What's up guys, welcome back to Ubad's lab, and today I'm going to be showing you guys how to set up the rate law equation for a reaction. Alright, so let's start with the information that we're going to be given in this problem. So say that the reaction can be represented by the variables A plus B goes to C. And then we also have experimental data as seen in this table. And there's 5 trials to this. And we record the concentration of A, the concentration of B, and then the rate of the reaction. And we see how changing the concentration of these two reactants will affect the rate of the reaction. So for example, in trial 1, the concentration of A is 0.25, and the concentration of B is 0.25, and then the resulting rate is 0.213. So the question is, how do we set up the rate law equation for this reaction? So let's start off by writing down the equation for the rate law. So rate is equal to K, which is the rate constant, times the concentration of A, the concentration of B, but there's exponents to these, so M and N, and these represent the orders of these reactants. So first we're going to have to find what these exponents are. What's the order of this reaction? And I'm going to be showing you guys 2 ways how to find this. The first way I'm going to be showing you guys is a bit harder and more complicated, but it's way easier to use on more complicated and harder problems. And the second way is way quicker, and I would recommend that when you see easier to follow numbers in your table. So let's start off with the harder way. So the way that we're going to be doing it is dividing 2 different trials, the equations of 2 different trials, and you have to have at least one concentration remaining constant. So the concentration of A, for example, from trial 1 to 2 remains a constant, 0.25 and 0.25. So we could use these 2 trials. So let's try that first. So rate 0.213 is equal to the, K, the rate constant, times the concentration of A, which is 0.25, to the M, which is the order, the exponent. And then the concentration of B is 0.25 as well. And then that's to the N. And now we're going to have to find the equation for the second one and divide it. So let's divide by trial 2. So the rate is 0.1065, and then K is a rate constant, multiplied by the concentration of A, which is remaining constant, so it will be 0.25, to the M, and then the concentration of B is changing, and that's 0.125, to the N. And dividing the 2 rates, 0.213 divided by 0.1065 is just 2. K divided by K is 1, so that cancels out. 0.25 to the M divided by 0.25 to the M is 1, it cancels out since we kept it constant. And 0.25 to the N divided by 0.125 to the N is 2 to the N. And now we have to solve for this exponent of N, and we can see that the bases remain constant, so we can set the exponents equal to each other. It's exponent of 1, so N is just equal to 1. Alright, and now let's try to solve for M, the other exponent, and the way that we're going to do that is by now setting the concentration of the other reactant constant. So let's look for a place in this table where the concentration of B remains constant. And we'll see that in trials 3, 4, and 5, the concentration of B remains at 0.100. So we can use any 2 of these. and we'll just use trial 4 and 5. So let's divide trial 4 by trial 5. So the rate of trial 4 is 0.1193, which is equal to K, the rate constant, multiplied by the concentration of A, 0.35, to the M, multiplied by concentration of B, 0.100, to the N, is divide this whole thing by the equation for trial 5. So the rate law for trial 5 is 0.0596. 0.0596 is equal to K. Concentration of A is 0.175. And then the concentration of B is remaining constant, so it's still going to be 0.100, and then to the N. So this time, we're going to still divide the rate laws, so 0.1193 divided by 0.0596 is also just 2. And then the K's divide out, and we'll just get 1 as well. And then this time, the concentration of B is what's going to be canceling out. 0.100 to the N divided by 0.100 to the N is just 1. So we'll cancel all that out. And then 0.35 to the M divided by 0.175 to the M is going to be just 2 to the M. And again, we can see that the bases are the same, so we can just set the exponents equal to each other. 2 is to the 1, and M is equal to 1. So now we have both of the exponents using the more complicated method. Let me quickly show you how you can use the faster method of just looking at the table and looking at trends. So again, you're going to be looking for 2 trials where the concentration of one of the reactants remains constant. So the concentration of A remains constant in trial 1 and 2. And then you look at by what factor the concentration of B is changing from one to the other. And we can see that from trial 2 to trial 1, the concentration of B is getting multiplied by 2. So we have to check what the resulting rate factor is, how the rate changes. So from 0.1065 to 0.213, it's also getting multiplied by 2. And since A is remaining constant and it has no say in this change, and then we know that the order of B has to be 1, since its concentration and its rate is going up by the same exact factor. So let's say this was different, and the concentration of B was getting multiplied by 2 from one to the other, but this time the rate was getting multiplied by 4. Then it'd be increasing by a different factor, and that'd be order of 2 that time. So that's something you just have to get used to, and once you get the hang of it, you can solve these rate law questions way faster through the method of just looking at the trends. And now that we got that down, let's solve for K, which is the rate constant. And this is pretty easy now that you have the exponents. All you have to do is just choose one trial and plug in all of the constants. So let's just use trial 3 since that's the only one we haven't used so far. So the rate for trial 3 is 0.0682 is equal to K times the concentration of A, which is 0.2, to the M, and we know M is just going to be 1. And then the concentration of B is 0.100, and then to the 1, since we know that N is equal to 1 as well. And then we can just multiply 0.2 times 0.1, and we get 0.02. Then we can divide 0.0682 divided by 0.02 to get what K is equal to, and that's going to be just 3.41. So K is equal to 3.41. And that's how you set up the rate law equation. Thanks for watching, guys. Don't forget to like, subscribe, and hit the notification bell if you enjoyed the video. And feel free to ask any questions in the comment section. And stay tuned for my next video where I'm going to be showing you guys how to make a disinfectant spray at home using hydrogen peroxide. So stay tuned for that.